Hi guys, welcome to the Elm tutorial part 5. I'm Tensor from the Tensor Programming blog. And in today's tutorial we're going to create a snake game inside of Elm. Now to create a snake game in Elm, we first need to think about what exactly a snake game does. Let's think about the snake itself. So what are the properties of the snake? So the snake moves in a direction at a constant speed. Snake has a body, and the body can be of different sizes. If the snake eats an apple, it grows. If we hit a key, the snake will move into a different direction. Also, we can't hit the opposite key. So if the snake is going in the right direction, we can't hit the left key. Otherwise, that would cause an instant failure state. Because, let's look at our fail states. So if the snake hits itself, that's a fail state. If the snake hits a wall, that's a fail state. This means that we need a window. And our window is going to be a grid. So our game is going to take place inside of a window, which is a grid. And then we also are going to generate random apples. So apple, it's going to be random. It's going to have a random x and a random y coordinate. Let's make that random. And random chance to spawn, and that's about it. So those are the basic properties of a snake. So the snake moves in a direction, snake has a body, when it eats an apple it grows. When we hit a key, we can move it in a different direction. We can't hit the opposite key. The snake eats itself, it dies. Snake hits the wall, the game ends. And it all exists inside a window, which is a grid, and various apples spawn with random x and random y coordinates, and they have a random chance to spawn. So now let's get our imports. First we need to install Elm into this folder. So to do that, we're going to first import the SVG library. Now if I run Elm install SVG, this is actually going to install the core library as well, because I haven't installed it yet. So if I hit yes twice, we get the core library here, as you can see, and the SVG library that we wanted. So we need the SVG library, we need the keyboard library, and we need the Elmlang window library. So now let's deal with our imports. So here we go. Here are the imports that we're going to need. We have the HTML app, which we always use. We have the window, which is going to allow us to render a grid that we can run our snake through. We have the time exposing the time type. We have the random library, which allows us to create randomly generated numbers. We have the keyboard library, which lets us access key codes, and it lets us access directions. We have the task library, which is going to let us handle commands. We have the HTML library, the HTML attributes library. It's exposing just style, because that's all we're going to need. And we have the SVG and the SVG attributes library exposing everything. I've divided our program into 4 different parts. The largest part of our program is going to be our update, because a lot of the game logic is going to happen there. Okay, so let's get started by writing our main function. Here's our main function. Our main function equals app.program, and it's going to take in init, which is going to take in init and init commands, because we have commands in this application. It's going to take in the update, the view, and the subscriptions. So let's start with the model. So the first thing we need to write for the model is the type alias of the game. So the game type is going to be made up of a direction type, or a direction element, which is going to be a direction type, a dimensions element, which is going to be our window, which is going to be the window size, the snake itself, which is going to be of type snake, whether or not the game is dead or the snake is dead, which means the game is over, which is a boolean. Our apple, which is a maybe block. This means maybe means that it could be there, or it doesn't necessarily have to be there. So it's a type that can be there and can't be there at the same time. It's sort of like quantum mechanics in a way. And the block type we have to create, which is going to be what we create our snake out of and what we create our apple out of. 8apple, which is going to also be a boolean. And it's basically going to decide whether or not the snake has eaten an apple. The next type alias we have to write is the block type alias. Our block is simply just going to be an x coordinate, which is an integer, and a y coordinate, which is an integer. We also need to write snake and direction. As you can see, they're throwing errors because we do not have these types in here yet. So let's write snake first. Our snake is just going to be a list of blocks. Our direction is going to be what's called a union type. As you can see, it's either up, down, left, or right. We also need to make a type called keys, which takes in the key presses that we're going to use. So in this case, our type of keys is going to have no key press, which means nothing actually has been pushed. It's going to have the left key, the right key, the up key, and the down key. We also need a type alias for apple spawn. So this is going to be a position tuple, which is going to take in a block basically. And then it's going to have a chance to spawn integer. Now we're going to write an init function for our snake, and the init function for our snake is just going to output a snake. Init snake function is just going to be a list, and it's going to be a list of blocks, and the blocks, so types in Elm can basically be used by functions. In this case, we're saying the block taking in the x and then the y. Now we need our init function, which is going to output a game type. So our init function is just going to be the initialization values for our record. So our direction is going to be right. Our dimensions for the window is going to just be 0, 0. Our snake is going to be our initialization snake. Our is dead is just going to be false. The apple is going to be nothing, and 8 apple is going to be false. And that's all we need for our model. Now let's talk about our update. So here is our messages. Our messages is a union type. We're going to have a message called arrow pressed. And if the arrow pressed, it passes through the keys type. We're going to have size updated, which is a window size type. We're going to have our tick time function, or message again. And we're going to have maybe spawn apple and apple spawn. Our update function is going to take in a message, it's going to take in a game, and it's going to output a game and a command message. We're going to do pattern matching for our key presses here. So if an arrow is passed through the message of arrow pressed, it's going to update the direction by passing arrow and game into this function update direction, which we have not written yet. For our update size message, we're going to pass dimensions through it, and the game is going to update the dimensions. So basically the size of the window is going to change. Tick is going to have time passed through it. This is going to be our update loop. It's going to update the game itself. We're going to make a function called update game, which updates the entire game. Now we're also going to have maybe spawn apple. It's going to take in a spawn, and then if spawn chance equals 0, then the apple is going to be spawned. And if not, the game is just going to run as normal. So let's write our apple spawn function here. So we're going to check to see if the is dead flag is true. If it is dead, then the game's going to stop. Otherwise, we're going to run a bunch of functions on the game itself. So now we're using the pipe operator. This little, it's using a pipe. It looks like a pipe anyway. Now the pipe operator lets us change the way that we apply functions to data. So in this case, instead of having the argument to the right of the function, we have the arguments to the left of the function. So this tuple is actually being passed into all of these functions. So it's being passed into check if out of bounds, then it's being passed into check if eaten by self, then it's being passed into check if ate apple, then it's being passed into update snake, and then update apple. I know that sounds convoluted, but it'd be like if we were running it like this. Here's an alternative way of writing it. That would be one way of applying this function to game command none. We use these pipes though because we're applying 5 different functions to this one tuple, and it would be really silly if we had to put, parentheses around all of them. So now let's write the check if eaten self function. This is going to take in a game and a command message and output a game and a command message. We're going to use a let in binding here. So now we're basically dividing the snake into the head and the tail. So basically head is the snake head, of which is going to be a function that we create. And then the tail is the list drop of the first element and then the rest of the snake. Then is dead is going to just be game is dead or list any. And if the head and tail are in the same position basically, then it's going to take that output, which will either be true or false. And this is another function that we have yet to write. And we're going to use these bindings to change this record, game is dead is dead. So we're going to say, okay, if the snake has eaten itself, then the game is dead is true, and it's going to end the game. So now let's write check if ate apple. This is also going to take in a game and a command message and output a game and a command message. So check if ate apple is going to use a let in binding as well. We're going to bind the snake head by using the snake head function with snake.game, or game.snake rather. Then we're going to run pattern matching on game.apple. If nothing's happening, the game.ate apple is going to be false, okay? So for every frame that we do not eat an apple, ate apple will stay false. But if we go over an apple with the snake head, then ate apple will be true, okay, for that one frame. That's basically what we're doing here. Now, same position again, it's another function that we have yet to write. So now we're going to actually write that same position function. Same position is going to take in 2 blocks and output a bool. And if we remember what our block type looks like, it's just an XY coordinate. So same position is just going to check if the A of X equals the B of X and the A of Y equals the B of Y. And it's going to output true or false based on that. So in this case, if it's true, it's going to change ate apple to true. And up here, if it's true, in the case of the head and the tail, then it's going to set the game equal to, or the game is dead equal to true, which is going to end the game. Next, we're going to write our out of bounds function. The check of out of bounds is also going to take in a game and a command message and output a game and a command message. We're going to use a let binding to bind the head variable to snakehead.snake game.snake again. Then we're going to bind an isDead variable to these here. And what this is basically doing is it's saying if the head X is 0 and the game direction is left, then the snake is dead because it's at the top of this screen, at the top left of the screen rather, and it's going left. If the game head Y and is 0 and the game direction is up, then it's at the very top right of the screen and it's dead. And the same here. It's the top, or sorry, this is the top right. This would be the right side of the screen and this would be the bottom of the screen. So we're basically just changing or making a new record that changes is dead to is dead. So it's basically going to say whether or not it's true if it's dead or not. We're finally going to write our snakehead function. So our snakehead function is going to take in a snake and output a block. So you got to remember that the snakehead, or the snake itself, is a list of blocks. The snakehead is just a block. So in this case, what we're doing is we're taking in snake, we're finding the list head of snake, and then if that value is weird, we're going to replace it with the default value of 0, 0. That's all this maybe with default is doing. It's basically making or giving the snake head a default value of 0, 0, xy. Now we're going to write our update apple function. This, like our other functions before it, is going to take in a game and command message and output a game and command message. So our update apple function is going to run pattern matching. First we're going to pattern match for nothing. So if game.apple is nothing, then we're going to assign a random integer to the chance variable. We're going to assign a random integer between 1 and 49 to the x and y variable. Then we're going to pair the x and y together. We're going to call this function here, this random or make apple spawn generator, to generate these random numbers and output the actual apple. So if there is no apple on the screen, so basically what this function is saying is if there is no apple on the screen, start rolling these dice. Alright? And as we wrote above, if chance equals 0, then an apple will appear on the screen. Once an apple appears on the screen, the chance and the random x and y's stop rolling. So these roll every frame. Alright, so now our second case is going to be just apple. So if game.ate apple, then game apple equals nothing. So if we eat an apple, then we're going to go back to this case of nothing, and it's going to start rolling chance x, y variables and pairing them together. and it's going to run this generator again. Otherwise, if there's an apple on the screen and we haven't eaten the apple yet, we're going to continue moving the game as normal. So let's make the makeAppleGenerator function. This is going to be type random generator apple spawn. We're going to use a let binding, and we're going to do a random pair of the spawn position. So this is going to roll random ints. So we're going to have another let in binding, and in this case we're going to bind spawn position to the random pair again. We're going to have spawn chance to the random int. And what this is going to do is it's going to map this anonymous function here of position and chance to position and chance. And then it's going to be placed here. So basically we're going to spawn an apple based on this here. This is a command. It's basically dealing with the command of rolling random numbers, which is a side effect. So now we're going to write our update snake function, which is going to take in a game command message again. So the way this function works is we get the snake head, and then we pattern match for the direction that the snake head is moving in, and we actually manipulate the way that the snake head looks by creating a new snake head. So in this case, the new snake head would be the y variable -1, this one would be the y variable +1, etc., etc., etc. Then we're getting the tail position, and if we ate fruit, the tail position actually doesn't move because it's growing. If we don't eat fruit, however, the tail position will subtract 1 because it's moving. You got to remember that the snake itself isn't actually moving because we're just creating a new snake every frame, and that new snake is basically quote-unquote moving forward or backwards or whichever direction. Then we're taking the tail x's and we're mapping the .x of tail positions here. We're getting basically the scalars of tail x, our .x tail positions, and you can write them like this. I showed this in our, I think, second tutorial that you can do this. And then we're mapping them to our block. So we're basically making a snake using this. We're making our tail using all of this here. And we're doing this inside of an if-then statement. So if game is dead, then do nothing. Else if game is not dead, then the snake equals the head prime cons the tail prime. So we're generating a new snake with this function. So now we need to make our update directions function. So this is going to take in the keys type, and it's going to take in a game and then output a game. The way this is working, as you can see here with our first statement, if the key press is the left key and the direction is not going right rather, then we change direction to left. So we're basically protecting from, if we're going right and we press left, that won't actually do anything. But in this case, if we're not going right and we push left, then we change direction to right. So now we need to write if statements for up, down, left, and right. Alright, so here's our completed statement. And as you can see with the right key, if it's not going left, then we can turn right. If we hit the up key and we're not going down, then we can turn down or up. If we hit the down key and we're not going up, then we can go down. Else we just pass a random direction, so it just continues going in that direction. Then we just use this to update our game direction. So now we're finally going to start looking at our subscriptions. So our subscription functions will take in a game and a sub message, and basically it's going to output a batch of subscriptions. So right here, as you can see, we have a subscription called arrows changed, we have a subscription called window dimension changed, and we have a subscription called tick. Now the sub batch function allows us to have multiple subscriptions, and that's what's happening here. So we need to actually define these subscriptions. Before that, we need to write a function called Init Commands, and then Init Commands is going to just produce a command message. So our Init Commands function is going to perform these tasks. It's going to update the size of the window size. Now we need to write our Windows dimension change function, which outputs a subscription message, and all this is doing is it's resizing the window. Now we need to write our tick function. So our tick function is going to be very similar to our clock tick function. So we're upgrading our game every 10th of a second here. So as you can see, time.milliseconds times 100, so that's a 10th of a second. And this is allowing us to update the game, so update the rendering of everything. So we render the snake, we render the window, we render everything based on this interval. Now we need to write our arrows changed function. So this is a sub message function. And this arrows changed function is just going to check the keyboard downs, which means if a button is pressed by the keyboard, then we're going to update this here, two arrows changed. This is another function that we need to create. Now our two arrows change function is going to take in a keyboard key code and it's going to output a message. So here it is, two arrows changed is just going to be pattern matching on the code that we insert, which is the keyboard key code. So each of these key codes corresponds with the arrow keys and it's type arrow pressed. So every time we push this, it's going to send a message up to the top to the update. There we go, arrows pressed, and that's going to match with keys here. It's going to manipulate the direction of the snake. So that's it for our subscription. Now we're going to actually build our view. So the first thing in our view is going to be a function called size. All size is a string. It's not actually a function. It's just well, it is a function because it's in Elm, but basically we're making a constant called size, which is a string, or a function called size that outputs a string. So this is going to be 100. Then we're going to have a background color, which is an attribute message. Now we're just going to fill it with a light gray. This is for filling our window. Now let's make our view function. Our view function is going to take in the game. And it's going to output HTML and a message. The reason I had to write HTML dot there is because we're not exposing the type of HTML. So we're going to use another let binding. So basically what we're doing with this function is we are just, with this let binding, we're just adding styling to our SVG. Now we're going to create our SVG element. So now we're just adding the attributes to our SVG element. So for our second SVG element, we're going to actually call three different functions. One of them is render background, the other one's render snake, and the last one is render apple. So we need to make these three functions before we finish everything. So let's start with render background. The render background function is just going to output an SVG and a message. As you can see, we're just making a rectangle here, in an SVG rectangle rather. Our render snake function is just going to take in a snake and output a list of snake messages. So again, we have another function here called render block, which we need to write. But that's being called on the snake as a list, or it's being mapped onto the list of the snake. Our render block function is going to take in a block and output an SVG message. And as you can see, our render block is just going to make a block. But yeah, we're just making an SVG rectangle, which is basically a square of 1 by 1, and it's light green. Now we need to make our render apple function. Going to take in maybe block and output a list of SVG message. We're going to run pattern matching, and basically if the apple doesn't exist, we're going to render nothing. If the apple does exist, we're going to render the apple. And I screwed up here. This needs to be lowercase. We have one more function, guys. I know this has been a long program. Our last function is going to be a scale function. It's going to take in window size and output a tuple of strings. So here's our scale function. We are making first an anonymous function here, and we're piping toString to the anonymous function. Then we're defining the height and the width by taking the float of the width and the float of the height. Basically, this scale is allowing us to make a grid out of our window. That's basically what this function is doing. Alright, so we are more or less finished. Let's take a look where there's an error here. I see what the problem is. We never actually wrote our update game function. In fact, our spawn apple function is our update game function. So let me rectify this. Here's what our spawn apple should really look like. I forgot a comma here, and this needs to be HTML attributes. After fixing a few errors, we have our snake game. As you can see, you move a green snake around the screen. You eat little green blocks. Now the green blocks appear after a certain period of time. That's based on the chance that we made. Alright guys, so this is the end of the tutorial. I hope you guys enjoyed. I will upload this code to GitHub. I have actually an alternative version that I've written that has features like pausing and other things. I just didn't want to, make a 500 line piece of code, though it seems we've written a 400 line piece of code, so maybe I should have just gone ahead and done it. So yeah, I'll upload this to GitHub. If you enjoyed this tutorial, please feel free to subscribe and like the video. If you disliked it, feel free to throw up a dislike, and if you have a question, please comment. Anyway guys, I'll see you next time.